So we've already talked about how to solve linear equations. So if you remember linear equations, the highest power was 1. So section 1.2 is more how to solve when the highest power is 2. So it kind of makes sense. Those are called quadratic equations. So what is a quadratic equation? What I just kind of said, it's just wherever the highest power is 2. So these are all equations of the form ax squared plus bx plus c equals some number, usually 0. So for example, 3x squared minus 2x plus 1 equals 5. That's a quadratic equation. Highest power is 2. I don't have any weird square roots or anything like that. It's just a nice quadratic equation. Something like 1/2 x squared equals 10. It's also a quadratic equation. Highest power is 2. Don't have anything weird like square roots, nothing, no cube roots, anything like that. That's a quadratic equation. Something like 1 over x squared minus 3 equals 8. This is not a quadratic equation. Can't have x being in the denominator like that. So it's just linear equations, but with this extra piece added on. Okay. So in section 1.2, we're going to go over 4 different ways to solve these types of equations. Now the first way that we're going to solve is called the square root method. Now the square root method only works on a very special case of quadratic equations. It only works when you have something of the form ax squared minus p equals 0. That's the only time the square root method is going to work. If you have something with that middle term, it's not going to work. So it has to look like this. Now how are we going to go ahead and solve this? Well, remember our goal is to get x by itself. So I'm going to first add to the other side to get ax squared equals p. Divide by a, and then take the square root. Now we want to be careful. Anytime you take the square root, there's a plus and a minus. So kind of an aside here. Think about this. What's 2 squared? Well, that's 4. What's negative 2 squared? Well, that's also 4. So because of this, anytime you take the square root, you got to include both of them. Because which one's the square root of 4? Well, it could be 2, it could be negative 2. So we don't know. So it's got to be plus and minus the square root of p over a. Okay, so that's the square root method. We're just going to kind of move that p over, divide by a, take a square root. So let's do some examples. Example 1. Let's solve 2x squared minus 18 equals 0. If I'm going to solve this for x, first thing I'm going to do is add that 18 over. So I get 2x squared is 18. Next, what do we say to do? Divide by 2. So I get x squared is 9. Now take the square root. Remember there's 2. How many square roots of 9 are there? There's 2. So I got minus 3 and also positive 3. Another example. How about x squared minus 5/2 equals 0? Well, I don't have a term in front of x squared here. That's okay. It's understood to be 1. But let's go ahead and solve this. I'll add the 5/2 to both sides. So I get x squared is 5/2. And now what am I going to do? Take the square root. But remember there's 2. So you can either write it as plus or minus square root of 5/2, or you can say minus the square root of 5/2 and plus the square root of 5/2. I actually think this is a better way to write it, just because it really shows that there are 2 answers to this problem. Okay, what about 2x squared plus 1 equals 0? So how do we solve this? Well, again, there's no middle term, so we can use the square root method. You're going to subtract 1, divide by 2, and now what? What's the square root of negative 1/2? You can try to use your calculator on that if you want. if you take the square root of a negative number, you're going to get an error on your calculator. So there's no answer to this. So we'd say there's no solution. So that's the square root method. You just got to remember it's something of the form ax squared minus p equals 0. You're going to get x squared by itself, then take the square root.